All right, number 3 is still in that numerical section of the homework questions in 4.7. So they're asking us to find a positive number x, and that positive is kind of important here in just a second. Can't be 0, can't be negative, such that the sum of that number, x, and its reciprocal is going to be as small as possible. Now, I actually want to deal with this second part first. This is something I didn't really talk about with you guys in class at all. Does this problem require optimization over an open interval or a closed interval? An open interval would suggest then that this number could be absolutely anything out there that we wanted it to be. A closed interval would suggest that there's kind of a limit here to what we could be dealing with. Well, that goes back to this idea that they told us this number has to be positive. So we're dealing with an interval here where the smallest value of x, well, there isn't really a smallest value, but it would have to be bigger than 0. There isn't really going to be a limit to how big it is. So this one is really optimization over kind of a semi-open and closed interval right here. It's closed on one side and open on the other. Regardless, let's get working. Now, step number 1 in an optimization problem is usually to write the parameter, the relationship between two variables, but I don't think we need two variables right here. In this problem, we're going to be adding two numbers together. One of those numbers is x, and the other number is the reciprocal of x that I think I can define without needing a second variable. So I'm going to completely skip step number 1 and go right to step number 2. Write an equation for the quantity we're trying to optimize. We are trying to find the sum of x and its reciprocal, and we want that as small as possible. So the sum of these two numbers right here is going to be the original number, x, added to its reciprocal, which is 1 over x. So that expression right there, x plus 1 over x, gets us the sum of whatever number it is that we put in there. So now for step 3, all right, because usually step 2 takes work. We've got to get it down to one variable by substituting one in for the other. But here it looks like that happened already. So now I think in step 3 we can find our derivative. S prime of x is going to equal, that's going to be a 1, and then the derivative of 1 over x, which is x to the negative first power, is negative 1, x to the negative second. So minus 1, and then that becomes an x squared on the bottom of that fraction. We'll take that derivative, set it equal to 0, and solve. So I'm going to bring this term over to the right and get 1 is equal to 1 over x squared. I'll reciprocate both sides. Well, the reciprocal of 1 is still just 1, and the reciprocal of 1 over x squared is just x squared. We'll take the square root of both sides now, and normally we would get a plus or minus 1 is equal to x, but they tell us right here x has to be a positive number. So I can forget about the negative case, and we'll just come up with this value right here of x is equal to 1. And now always, guys, step 4 is to answer the question that was asked. So if I go back and read this again, starting right here, find the positive number x such that the sum of x and its reciprocal is as small as possible. I just found what that number was, guys. X is equal to 1. So that's the answer to the question. I haven't actually proven anything, though. So real quick, let me just dabble with this real quick. What I think I found, what maybe they could have asked me is, what actually is the sum when you put a 1 in there? So we're going to add the number 1 plus its reciprocal. Well, the reciprocal of 1 is also 1, and that sum is 2. Now watch what happens if I picked a bigger number, like 2 maybe. I would add the number 2 plus its reciprocal, 1/2, and get 2.5. That number, pretty clearly, is bigger than 2. We wanted that sum to be as small as possible. So, okay, this seems to make sense. If I had gone smaller than 1, let me make it interesting, like 3/4, we would be adding the number 3/4 plus its reciprocal, which would be 4/3. Well, I'd need a common denominator to add those two. That common denominator would be 12. So this would be a 9 over 12, gotcha. I'd multiply the next one by 4 over 4, that'd be 16 over 12. That becomes a 25 over 12. And I'm hoping you can see pretty quickly that number is just a little bit bigger than 2. So what I'm doing in red here doesn't really prove anything, but I tried picking numbers bigger than 1 numbers smaller than 1, both of which gave me a sum bigger than 2, so I do believe that 2 is that minimum possible sum. Now again, the question could have been phrased that way. What is the minimum possible sum of a positive number and its reciprocal? In that case, the answer would have been 2. But always go back and read, answer the question that they're asking. Find the positive number x such that the sum of x and its reciprocal is as small as possible, so my answer here is x equals 1.